All right, so in these two examples, we have a graph. We're supposed to write the standard equation. Okay, so the first thing you want to look for is the center. So this one's pretty easy. We have a center at 0, 0. So since it's at 0, 0, we don't have to worry about that h or k. It's just going to be an x squared and a y squared. Going to equal 1. All right, so now to figure out what goes under x squared, we look at what's going how far to the left and to the right of the center we're going. So from 0, 0, we go to 8, 0. So since we're 8 away, it would be 8 squared. Going up and down, looks like we are 7 away. So that would be 7 squared under the y. Okay, so if we simplified it, it'd be x squared over 64 plus y squared over 49 equals 1. That would be your solution there. Okay, and the next one, so again, start with the center. So our center is right here, which is at the point 1, 2. So we're going to have x minus 1 squared on top and y minus 2 squared on top equal to 1. Okay, now to see what goes underneath the x, we look how far to the left and the right we go. So it looks like we're going 1, 2, 3, 4. Okay, so since it's 4 away, 4 squared is 16. Y, so how far up and down? We're going up 2. 2 squared is going to be 4. So that's the equation for that one. Okay. So not really too hard once you get the hang of it. Finally, word problem. It's really not that bad. So it says the tunnel is in the form of a semi-ellipse. So that would be half an ellipse, right? Imagine a tunnel kind of like that. Can be modeled by the equation x squared over 100 plus y squared over 64 equals 1. Engineers want to design a tunnel that is twice as wide and 1.5 times as tall. So our center would be here at 0, 0. So this length, so you look under x, square root of 100 is 10. So it would be 10 here and 10 here. Square root of 64 is 8, so this would be 8, right? So then if we want it to be twice as wide, so dimensions of the larger tunnel, so twice as wide, it would be twice of 20 is 40 feet wide. And 1.5 times as tall. So 1.5 times 8 is 12 feet. Okay, what's the dimensions for the larger tunnel? So our larger tunnel now, okay, this is 12. Since it's 40, it's 20 and 20. Okay, still at 0, 0. So our equation, we have x squared and y squared on top. All right, and so under x squared, we're 20 away. So 20 squared is 400. And for vertical, we're 12 away from the co-vertex. And 12 squared is 144 and equals 1. So that's those two examples there. All right, so your assignment, it's another worksheet, so I'll post that as well. Where there is work to be shown, so you know, on these, there's really not, you know, much work, so to speak. But like if you're finding like C here, like I should see some work for that. If you're needing to do any Pythagorean theorem stuff like you did here, or when you have the problem like this, I should see your distance formula work. So show a little bit of work, make sure you read the directions, and yeah, try to do it without looking at the answer key first if you can. So that's it for the 10.3 lesson. Next we'll be having a quiz, so make sure you review for that and then take the quiz when you're ready.